So here's our example. We want to approximate the area of the plane region caught between y equal x squared plus 1, the x-axis on the closed interval from 1 to 3 with n equal 4. So I graphed y equal x squared plus 1. It is above the x-axis over the interval. My interval starts at 1 and ends at 3. So I drew a vertical line up to the function at x equal 1 and a vertical line up to the function at x equal 3. And then I want n equal 4 sub-intervals. So 4 rectangles is what we're using. But because it's caught between the curve, the x-axis over that interval, the shaded region you're approximating the area to is this shaded region. So now when we go through our steps, first we want to find delta x. Well, delta x with our equal sub-intervals, we find by taking the b, the right endpoint of your overall interval, minus a, the left endpoint of your overall interval, divide by your n that they request. So it's 3 minus 1 over 4. So that's 2 over 4 or 1/2. Now I want to find my subintervals. So my subintervals, my first subinterval starts at the beginning of your interval. So it's going to start at 1. And then take 1 plus delta x. Well, 1 plus 1/2 is 3/2. And then the next one starts at 3/2. And 3/2 plus 1/2 is 4/2 or 2. Then the next one starts at 2 and ends at 2 plus 1/2 is 5/2. Then starts at 5/2 and ends at 5/2 plus 1/2 is 6/2, which is 3. So notice I have 1, 2, 3, 4 subintervals, and it landed me at the end, which matched up with my b. So when we look at this, my start, my x sub 0 is 1, my x sub 1 is the 3/2, my x sub 2 is my 2, x sub 3 is the 5/2, and x sub 4 is my 3. And technically, you probably could have found your x values first and then broken up your subintervals. It's just however you think about it when you're going through. Okay, now let's find the heights. So for my right endpoints, we can look at our subintervals here. My right endpoint of my first interval is the 3/2. So for the right endpoint, that's f of x sub 1, which is f of 3/2. But remember, that means go to your function of your question. Take out the x's and put in 3/2. My function is x squared plus 1. So 3/2 quantity squared is 9/4, and 9/4 plus 1 is 13/4. Then f of 2. Well, 2 squared is 4 plus 1 is 5. And then f of my x sub 3 is f of 5/2. 5/2 squared is 25/4. 25/4 plus 1 is 29/4. And then f of 3 is 3 squared is 9 plus 1 is 10. Now let's do our left endpoints. Well, the left endpoints are starting at x sub 0 and going to x sub n minus 1. So that's going to be f of 1. 1 squared is 1 plus 1 is 2. It'll be f of 3/2. We already did find that in the first stage. That's 13/4. It'll be f of 2, which came out 5. And f of 5/2, which came out 29/4. So then if I'm approximating the area using the right endpoints, the area is approximated by taking and adding up all of those rectangle areas. And you're going to do height times width. So for the right endpoints, I'm going to go 13/4 times my width of my rectangle, which is your delta x, so times a half. And then plus 5 times a half. And then plus 29/4 times a half. And then plus my 10 times a half. And so as we get that, we have 13/8, and I'm going to go everything into eighths so it's easier to add up. So 13/8 plus, well, this would be 5/2. But building that so it's in eighths, I need to build top and bottom by a multiplication of 4. So that's going to be 20/8. Plus this is 29/8. And then plus, well, 10/2 put into eighths will be 48. So then we get our 102/8. And so 51/4. Okay, so then let's look at approximating the area using the left endpoints. So I'm going to do the left endpoints of each one. We found the heights using the left endpoints already. Remember, our area is adding up the area of the subrectangles. So height from your output of your function, width from your delta x. So that's going to be 2 for the height times 1/2 for the delta x plus 13/4 for the height times the 1/2 times the width plus 5 for the height times the 1/2 for the width, and then plus 29/4 for the height times 1/2 for the width. So we get our area is approximately, and again I'm going to go to eighths. So 2 times a half is 1, but in eighths that's 8/8 plus 13/8 plus 5/2 turn into eighths is 28, and then plus 29/8. So then we have 78, which my area is approximately equal to common factor of 2 top and bottom gives me 35/4. And then certainly we could go into our decimal form of these fractions if you wanted to do that and then just get a feel for those values. But the other thing I want to also mention is if you then broke this up on the grid scaling that you have and counted the number of square units that are enclosed by this region, these numbers would approximate that number of square units because it is the square units of area that you're approximating. So thank you for watching my videos, and I hope you have found them helpful.